Okay, our next speaker coming up, David Moloney. I actually have met David first when he was still CTO of Movidius, a company he has co-founded. And Movidius has been, as you probably all know, meanwhile acquired by Intel. And David has been appointed as Director of Machine Vision Technology in Intel's New Technologies group. David has worked in the semiconductor industry internationally for the past 28 years or so, with Infineon in Germany, STMicroelectronics Electronics in Italy, Parser Siva, Frontier Silicon in Ireland. And he's an expert on high-performance computing and computer vision. And in his talk today, David will share with us what we can expect from the combination of modern edge devices and artificial intelligence. So let's welcome David.
Hello, everybody. Thank you very much for the opportunity to speak here today, Gabrielle. I'll be covering kind of more what we're doing in the hardware side of Intel on enabling edge inference, and my colleague Alex Mayakov tomorrow will be giving a talk more on the software and algorithmic side. But we started actually in Movidius quite a few years ago, in 2008, 2009, in what eventually turned out to be computer vision, and we got to where we are now by a process of degrees. Starting off on dual camera stereo setups, and we've kind of learnt along the way. First major engagement would have been with what's now Google's Project Tango in about 2011, and that then led to getting involved with DJI, who are the preeminent drone supplier. And it's been a continuous kind of learning process for us, really, especially trying to invent a new category when we introduced the very first vision processing unit in 2014 at Hot Chips in California. So what I'm going to discuss today is, what we're doing specifically in the area of edge inference. This, if you're in an industrial application, this may not be as important for you, unless maybe if you're trying to retrofit an older factory where you can't string, Cat5 cables everywhere, and maybe you need to, do more processing locally to look at an older piece of equipment or gauge and provide analytics and metadata back to a server. So I think whereas it's maybe not mainstream for a lot of you, there are definitely points of contact with the kind of markets that you're looking at. So, it's a hugely growing market. Raj has talked about, a billion cell phones enabled by Qualcomm silicon, and there are obviously there's huge potential for that kind of silicon in this kind of application. And Marco has explained, how you can use SIMD processors similar to what we're using ourselves with the right memory subsystem to build more bespoke solutions. So I guess what we're doing as a division of Intel is slap bang in the middle. It's something that's aimed specifically for computer vision and inference, and targeting this highly growing market. And obviously, we've kind of topped out pretty much in terms of how many cell phones a person can carry around with them. So now we're talking about, well, what are all those other devices that can surround a cell phone or can be in the environment around us and can provide useful functionality, whether that's in a factory or in a home. So, in terms of what we mean by edge inference, it means that, and I don't need to tell people in Germany about this, very well from East Germany. Privacy is a huge concern with any kind of vision system, because you don't know if it's going off to a cloud, who it's going off to. We have, the GDPR regulations that are starting to come in here now in Europe. I got email this morning telling me that I need to switch some of the preferences on my Google account. So this is going to mean, I think, an increased impetus towards edge inference, particularly when humans are involved. And let's say even in a factory environment, you may be capturing people. So this may not be a don't care issue even for people in a more industrial setting. But essentially, when you're talking about local processing on a device as opposed to in the cloud, Mark Horowitz, who's professor in Stanford University, says there's about 6 orders of magnitude between doing register-to-register operations in an SoC compared to shipping those the raw pixels off over the broadband network to a server to be processed. There's obviously a continuum here. So I mean, we're talking about applications that are in anything from tens to a few hundred, and maybe even up to a watt kind of dissipation. Obviously, if you use something like a smartphone, it's significantly higher than that, because you have to run the modem, you have to run a display and everything else, and then it rapidly goes off the charts when you start talking about trying to do inference and vision processing in the cloud. So what we've done is to essentially build a bespoke solution which consists of hardware acceleration, of a mixture of hardware acceleration and VLIW processors, of which we have 16 on the new Myriad X device that we announced a few weeks ago. And on top of that, we have all the connectivity in terms of MIPI, PCI Express, USB 3.0, etc. So it's really a system where you can build a multi-camera solution. Let's imagine you have a conveyor belt, and you need to connect multiple cameras to get a view of, I don't know, apples or some other something else that you're integrating or you're inspecting on a production line. Well, you're going to need that kind of camera rig, and this kind of device really allows you to do that kind of processing. We're currently on our 3rd generation of product. And if you look at what this device is actually doing, and it's shipping in millions and millions quantity, it's enabling things like drones, it's enabling surveillance cameras, it's enabling AR, VR and MR kind of devices, and it's enabling wearables, and I'll describe in some detail some of those applications. So very interesting edge-based application that was announced last week by Google is this little Google Clips camera, and some people currently use things like Google Photos to capture the images of their family, and Google very nicely has some deep learning in the cloud that turns these into nice little video clips and even adds music. But I guess for many people it may feel a little bit creepy to be uploading all of your private photos to the cloud. And what this device really is based on Myriad 2, the whole brain of the camera is Myriad 2. It's got a simple on-off switch. You can use the smaller switch down below, the white one, to teach it what a person looks like that's of interest. So if I wanted to, I could take a picture of Gabrielle and Alex there in the front, and I could say, okay, when they're in the frame, now take pictures. And what this camera does is it has deep learning inference built into it, and it can decide, okay, I've recognized the people who are in the scene, and I know what a good scene looks like, and it can basically proactively capture content and churn out little 7-second video clips that reside on the camera, encrypted until you've got a paired device like a phone, and then you can decide as a user whether you want to upload that and show it to your children's grandparents or whatever. So this is really a device that wouldn't have been conceivable to build even a year or two ago, and this is basically being built up from the ground up around Myriad 2 and the unique capabilities that it provides. Other devices, and probably the better known devices that we have in the market at the moment based on our technology would be all of DJI's drones. And from the Phantom 4 about 2 years ago, essentially the must-have Drone features like collision avoidance have been provided by our silicon and in the preeminent drone provider. You can see here what the internals of the Mavic Pro look like, and the Myriad 2 die features rather strongly in there. What's probably even more interesting is that in the later generations of drone, you're talking about not just doing collision avoidance, which is typically based on stereo depth. You're talking about also recognizing people, recognizing gestures. So let's say the DJI Spark, which is around about €500 device, you can take off from your hand. You can basically push it away, get it to come towards you, get it to pan left or right, do selfie gestures and so on. So the engineers in DJI in Shenzhen have done a fantastic job of building all of this technology on top of the hardware and software that we provide them. The kinds of systems that you see here being built now, they're no longer just a single camera. You're talking about multiple systems running in parallel. So you might have collision avoidance, you have gesture recognition, you have person detection, and you have more kind of UI functionality, all running at the same time in parallel. So you're talking about having a system there that can allow you to program and deploy very, very complex systems that typically wouldn't have been possible to do at all in an embedded context. In addition, you might have things like video recording. Hikvision, based in Hangzhou in China, have announced a series of cameras based on our technology, and these cameras really, it's not just detecting number plates. I mean, they can go way, way beyond that with the inference that's built into the camera without having to have a high bandwidth connection. And what the end users for these cameras are interested in is being able to, for instance, not just look at the number plates, but they want to see does the number plate correspond to the type of vehicle. Does it correspond to the color of vehicle? Are the people in the car the same ones who were in the obviously to see if somebody's changed the number plates for criminal purposes, and that they can correlate all of those factors and do all of that at real time at very high resolution on cameras that, and maybe only have a few of these across a few lanes of a large highway, and this is basically all technology that's available in the market today based on our platform. So what does the platform consist of? And I think it's in some ways quite similar to what Marco was talking about. So you have an array of processors. You have different vision accelerators that are part of the mix there as well, and you have overall CPUs, and then you have all the interfaces. One of the kind of really key things, and Marco alluded to it, is in order to get down from 3, 4, 5, 6, 7, 8 watts down to a 1 watt where we are, you need to take huge account of data movement. So that means basically having a very high availability, high bandwidth memory subsystem on chip that can supply all of those devices. So on Myriad 2, that memory subsystem can supply at about 409 gigabytes per second of on-chip bandwidth. So I mean, outside of FPGAs, I'm not really sure of any platform that can do that kind of thing, and that's really one of the enabling pieces. Also, earlier Raj and many people in the audience were asking, well, how do you program these things? Thankfully, we don't have quite the same level of difficulty in programming this device, because it's really aimed at ISP, computer vision, and deep learning. So you can handle that rather straightforwardly using APIs and using graphical tools that we've developed to make it easy for people to kind of drag and drop components. So a lot of the computer vision kernels would be wrapped as components. You can basically connect those a bit like you would do with Simulink, if people are familiar with Simulink. And at the end of the day, the compiler for that representation spits out the configurations for the DMAs, the memory subsystem on board, and so on. So it makes it much easier for people to kind of plug and play components, to take basic pipelines that we would have defined for different customers, and then to modify them for their purposes. If they have some special algorithm, let's say a special sensor that's being used in an industrial setting, or a special white balance, or some other thing. Let's say if you're in underwater ROV, you might have completely different algorithms because of the way that light is transmitted underwater, etc. The other kind of key thing that we've done, and it was announced on Wednesday, so 2 days ago, was full not only Caffe support but TensorFlow support. So what that means is that if you have a network, and with the means that we deploy this via is this neural compute stick, you can buy them for about $79, I believe, or similar number of euros from the sites like Mouser and Arrow and so on. And this device basically allows you to do accelerated inference. So you can take a network that you've trained on AWS or on your PC with big GPUs on it, and you can take that network, you can press a button, and a compiler basically will generate a binary blob which runs on the chip, and basically populates the DRAM that's packaged in the same die with the network weights that you require to operate the network. And this basically allows you to do much higher frequency inference than you might otherwise do. So Myriad 2, I think for GoogleNet is something about 15 hertz. And the new Myriad X device, which has hardware acceleration, is in the range of 150 hertz, all at a watt or thereabouts. Gabrielle mentioned that we know each other, and we've had the pleasure of knowing each other for a couple of years on this European project. So this is really a project that was aimed at bringing edge inference to people who didn't have the resources that they would require, that larger companies can bring to bear on problems like this. So it was really trying to allow people to add that computer vision feature to a product or service that they already have, without having to deploy a team of 10 or 20 people to do it. And we're coming to the end of this project now, but we've basically developed a platform based on Myriad 2 here on a lot of different sensors. You can even connect easily via connector other sensors. And the ethos of the project is very much open source. So all the schematics, the layout, the software developed by the consortium is basically open source. And the idea here is really to enable industries, and obviously we have quite a few European industries interested in using the platform. And it's basically royalty-free, license-free platform. It's very easy to sign up and use it. And we have customers and partners across Europe who are using this to start working on innovative products and services. And by the way, all of the neural network inference that I showed you also runs on this platform. So you can build very easily devices with the capabilities of something like Google Clips using this platform. One of the key things in terms of achieving low power there is to have an event-driven paradigm. So you use different sensors and different, maybe level thresholding initially, and then more sophisticated algorithms as you go up the tree, getting to a full activation state. At that point, then you do your full inference on, IMU, on face, on whatever other parameter, on audio, for instance. And then you can basically over Wi-Fi and over MQTT, you can stream even video over RSTP, and that way you can basically show with a very, very small, low power, battery powered embedded device, you can deploy all sorts of sophisticated services. So the kinds of things that we've done in terms of use cases with EOT here, with a company based in Austria, has been on a next generation museum guide. So you kind of take in video and you provide audio narration of what the people are seeing. So you don't need to kind of go out and plan. You could even reorganize the way that things are exhibited in your museum dynamically from day to day, and the system could potentially adapt to that and still be able to guide people efficiently through the museum. We've done another thing, which is a peephole door viewer, and these things seem to be really popular, particularly in China. There are lots and lots of people who are interested in making these devices, but it's very interesting. Maybe with an aging population, you don't want to have to open up the door unless you know who's going to be there. So if you can have something that can tell you on your smartphone, so you don't have to open the door to see who it is, you can see how there's value in that. We've built a versatile mobile platform, camera platform, which is very much in the spirit of Google Clips. And then something more in terms of the social interaction, smart doll with emotion recognition. Again, a lot of people might find that quite creepy, but I suppose this is more a way to say, okay, you could have systems that can interact with you. So if you're an older person living on your own, you could have a machine there that can recognize, okay, you're looking good or you're not looking good, and it could let trusted people like your kids know if you're not looking so good today, or the system could see maybe you're looking a bit sad. It shows you one of your favorite soaps or some movie to cheer you up. I mean, you can imagine lots and lots of kind of social robotics applications for that kind of device. Again, nothing particularly industrial about any of that, but this is really a platform to show all those kind of capabilities. And as I mentioned already, there's a whole lot of software has been ported by the partners, including, very interestingly, MicroPython. So what that means is that a lot of the core functionality in the platform can be exposed via MicroPython API. So it means you don't necessarily need to get down into the guts of an application, of optimizing an application for a complex platform to be able to build at least something at prototype level. You could potentially do that using the MicroPython API and be able to show something to your management so they don't get too worried about what you're doing in the lab for the past 6 weeks if you can put together something quickly. So it's very much in that kind of hacker spirit, I would say, where to be able to quickly demonstrate for a small company or design team what can be done. So that's quite a lot of information. I guess what we see here is we see a huge explosion in the next few years of these kinds of edge device. You're kind of reaching saturation in a lot of other areas of the market, and really we feel that things that we're talking about maybe 15, 20 years ago, like the disappearing computer, are really starting to happen now with the advent of devices like Alexa, but they tend to be tied very much to a back end that sits in the cloud somewhere. But you can imagine having speech control of devices that otherwise, where you can have contaminants or you can have abrasives and so on in an industrial setting. If you can deal with the background noise, is very useful. And any of that kind of technology is going to be kind of a hybrid of algorithms that and love and work in your environment, but then probably with the additional pixie dust of some deep learning there to take care of those outliers that maybe typically require somebody to get in and maybe spend a week or two in the factory optimizing things. That's potentially some upside for deep learning in some of the areas that some of you are in. As I said, the platform here is deployed in the mass market already and is delivering these exceptionally high levels of performance at very, very low cost and levels of battery power. And it's I suppose in front of a European audience, I'm very proud of the fact that this is technology that's been very much built in Europe from the ground up in Dublin, where the hardware team are based, and in Timișoara in Romania, which if any of you are in the automotive space, you'd probably be familiar with it. There are many German companies out there, and that's where a huge component of our software team is. So thank you very much.